Hello. Good morning, everyone. I hope you're ready, because my talk is going to be a really big change of context, pace, as well as content. I'm going to be talking about a lot more technical stuff. There's going to be a lot of code. I'm specifically going to talk about the document side of SVG. So over the last 3 years, I've been working a lot with SVG, and I've been seeing a lot of developers use SVG a lot more than they used to do before, which is amazing. But I've been seeing them, like there's usually a focus on two specific things in SVG, either using them, oh, there's a doggy here. Using them either to display small icons and illustrations, or to animate icons and illustrations, or even bigger stuff, but it's usually either displaying simple static images or animating them. But SVG, because of its nature as both an image format and a document format, it can do a lot more than that. And the document side of SVG is not usually touched a lot. I'm not sure if it's because developers don't know of what's possible with SVG, or maybe they haven't had the time to dig into it. So I'm going to go over just some of the things that you can do with SVG. Hopefully, they will be able to inspire you to do more. Actually, did you know that SVG is so powerful that in Doctor Who Season 7, Episode 2, missiles are being guided by the power of SVG? That's pretty cool, huh? Now, seriously though, there is so much that you can do, and I'm only gonna be covering like 4 or 5 things. I'm going to be starting with cropping, scaling, and preserving aspect ratio using SVG. Now, in particular, I'm going to be showing you how you can use SVG, how SVG can be used to replace certain CSS features when the browser support for those features is not really that good. Now, this is not an SVG versus CSS thing. These two work fantastically together. But there are certain things that we can do with CSS that were actually imported from SVG, and browser support for those features is not really that good yet. So in the meantime, you can use SVG as long as you know about how those things work in SVG. Now, when we talk about cropping, scaling, and preserving aspect ratio in SVG, there are 2 attributes in particular that we usually talk about, that they will do all of this work for us. The Svg View Box, what I like to call the Svg Superpowers, and the Svg Preserve Aspect Ratio attribute. I like to call the cousin of the View Box, or the best friend, because they do amazing things together. Now, these 2 are the most powerful and possibly less or underused attributes of SVG. Now, before we get into how these 2 work together and how we're going to use them, we need to be able to differentiate between the Svg View Box and the Svg Viewport, because there are 2 different concepts. Now, the Svg Viewport is the viewing area of the SVG. You can think of it as a window through which you see a certain scene, just like a regular window. The scene could be visible in its entirety or just partially within that window. Now, the size of that window, every window has a finite size. The finite size of this window is determined by the width and height attributes on the root SVG element. For example, in this SVG here, the black borders in this example are the borders of the SVG, and they are defined using the width and height attributes on the SVG element. And they establish what is known as the viewport of the SVG. The viewport is what the browser uses to determine how the SVG behaves in the context of the page. Just like any other HTML element that has a width and a height, the browser uses those dimensions in order to lay out the entire page. And if you change the width and height of an HTML element, it's going to affect the entire layout, and there's going to be repainting and relayout. This is the kind of width and height that SVG also has. And just like HTML elements, the width and the height establish a coordinate system on the SVG. That coordinate system is called the initial coordinate system. But this coordinate system is not what it may seem at first. So what you see here, the cat inside of the borders, the browser does not use the initial coordinate system of the SVG, of the viewport, to draw the SVG on the canvas. Because conceptually, the canvas is infinite in both dimensions. So just a quick definition. The canvas is the space or the area where the SVG content is drawn. Conceptually, it's infinite in both dimensions. However, it is rendered on the screen relative to a finite region known as the viewport, our rectangle. Areas of the SVG that lie beyond the boundaries of the viewport are clipped off and not visible. Now, I like to think about SVGs in this sense as being similar to Google Maps. So you have this small finite area, just like an iframe. You see only part of that map, but if you drag that map around in the background, you can see a lot more. So whenever I think about SVG and I have to think about viewport versus canvas, I think about it literally as 2 layers. There's the front layer, just like a stencil with a small rectangle, and then there's the back layer where all of my drawing is taking place. Now, in order for the browser to be able to draw on that infinite canvas, it needs a coordinate system. And because it does not use the coordinate system of the SVG width and height, it's going to need another coordinate system. So yes, we have two coordinate systems in SVG. The coordinate system created inside of the SVG on the canvas is created using the Svg View Box. That's what the View Box is for. So we have Viewport, which is the window, width and height, and we have the View Box, which is the coordinate system on the canvas. The coordinate system on the canvas has a different name. So we had initial coordinate system on the Viewport. I've been doing this for 3 years and I still have to Viewport versus View Box. Initial coordinate system versus user coordinate system. You're rarely going to be using those names anyway, so it's usually Viewport versus View Box. Now, the Viewport takes 4 numerical values. It's made up of 4 values. The first two determine the coordinates of the top left corner of the coordinate system, so initially, basically, where the coordinate system starts. And then you have the width and the height of the coordinate system, because even though the canvas is infinite, the coordinate system has to be finite. Now, together, these values make up the coordinate system, and they are initially identical to the initial coordinate system. So when you create an SVG in Illustrator, for example, and you export that SVG, you're going to find that the View Box, the width and the height on the View Box are going to be identical and equal to the width and the height on the SVG. This is the default state. But things start to get a little bit confusing and too exciting when you start changing these values. And this is where I'm going to be using my different coordinate system demo thing. Okay, let me make it bigger. So I created, I'm going to make them identical at first. So the gray coordinate system that you see here is the coordinate system established on the SVG. So the SVG is 800 pixels wide by 600 pixels high. And initially, the coordinate system on the canvas, which is the View Box, is identical. This is what we have here, okay? Now, by changing the values, I created this demo 3 years ago when I was first getting into SVG. I started changing the values of the View Box. Unexpected things happened. I banged my head against the wall for 2 weeks before I got finally to the aha moment, where I figured out the difference between them. And the only reason I was able to do it is because I created this to visualize them. Otherwise, it would have been really difficult. So, View Box, Viewport, they are initially the same, but you can change the value of the width and the height of the View Box inside. So if you make it bigger, the aspect ratio of the View Box inside of the SVG is different now, but by default, the browser maps the View Box coordinate system to the Viewport coordinate system. So by default, even no matter how big the View Box becomes, it's going to be contained inside of the Viewport. Contained or not contained, that depends. You can also control that. Say you also want to change this. Now, the first thing you may have noticed is by changing the values of the View Box, by making them bigger, you're scaling the contents of the SVG down. If you make it smaller, you can scale the contents of the SVG up. So this is one of the ways that you can manipulate SVGs using the View Box. Now, the min X and min Y, the X and Y are outside the scope of the talk, so I'm going to be not going over them. So right now, assume that you have some content inside of the SVG. The View Box has a different aspect ratio from the SVG. So you have some white space at the top, white space at the bottom, that's fine. Just like background images in CSS, you are able, in SVG, you can tell the browser if you want the entire View Box to be, yeah, you can see it in my mouse. If you want the entire View Box to be contained inside the Viewport, or if you want it to cover the entire Viewport area. Background images in CSS, if you set the background size to contain, you're going to get this result. If the background of the element has a different aspect ratio from the element itself, you can tell the browser to either make it be contained inside of the element, which means that you will get some white space on top and on the bottom, or left and right. Or you can tell the browser that you want it to scale it up as much as possible to cover the entire background area, even if that means cropping out some parts of the image. Now, you can do exactly the same thing with SVG if you use the preserve aspect ratio attribute. Now, this is what I have here. Keep in mind that this drawing here, you could have anything on the View Box. I just happen to have a parrot here because I'm a bird person. I don't have much against cats, but I'm a bird person. So I have a parrot here, and I have a lot of white space here, but you can imagine an entire SVG scene or illustration. Now, if I change the value of the preserve aspect ratio from meet, which is the same as contain in CSS, to slice, which is the same as cover, I get this. I don't have any white space at the top and the bottom. So this is the View Box, where the View Box starts now at the top. But what's happening here is the view box, the canvas, has been scaled up as much as possible to cover the entire viewport area, and it happens to be white in my case, but it has been scaled up. Initially, it is center, just like the background position, center, center. You can change the position of that image as well. For example, sometimes you position a background image in CSS by saying top left, so it starts at the top left corner. You can do that as well. Using X-min, Y-min, it's similar to top left. You can get this. You can also, the default value is X-mid, Y-mid, which is the center. You're centering it this way. You can also choose X max, Y max. So now I'm showing the bottom right area of my canvas inside of the viewport. Now imagine using this. So suppose you have an image here, any kind of image that has a different aspect ratio from the container of that image, and you want to be able to crop that image and position it inside of that container any way you want. This is possible with SVG. So let's get back to, no, not, yeah, that's it. So as you can imagine, just to recap, because of our ability to use and manipulate the inner coordinate system, we're able to create all kinds of great effects and techniques to do a myriad of things in SVG. One of these things is cropping and preserving aspect ratio of non-SVG images. So CSS currently does that. We currently have the object fit and object position properties in CSS. Using object fit, the contents of an image or a video, for example, could be also a video, can be set to scale up and down, shrink or stretch as necessary to fit into the width and the height you specify. So for example, suppose that you have an avatar image. All of the avatar images need to be square, okay? And you have a CMS like WordPress, and you're allowing your authors to upload images of their own. They don't upload a square image, so you're going to have to be able to crop that image and scale it and put it inside of that square area that you have. This is possible in CSS using object fit and object position. Object position tells you how you can position the image, and object fit does something like this. So I have an image here, again a duck, and I have a square. So you can tell the browser if you want the image to be fit inside of the square without preserving the aspect ratio, so it kind of shrinks horizontally here. You can tell it that you want it to be contained, which creates white space at the top and bottom. You can tell it to cover it, which is the most used value. So it covers the entire square area and crops out any extras, and it's going to be centered by default. None means that it's not going to be doing any scaling or stretching at all, and scale down is very similar to contain with very minor differences. This is pretty cool. So using just one line of CSS, you can allow your users to upload any kind of images that they want while preserving the aspect ratio in your designs. But the browser support is not really good. And as usual, our main problem is Internet Explorer. Even MS Edge currently doesn't support it, but it's coming in this upcoming Edge version. So suppose that you do still need to provide support for IE. So you will probably want to look for a different solution. So you can either use this as an enhancement if you don't care about IE, if you can start supporting only the latest versions of all browsers. I do have clients who do that, by the way, which is amazing. I mean, it's 2017. So you can check support for object fill. By using the supports rule, you only apply the CSS styling of the images if the object fit property is supported, which is pretty cool. But if you want to support older browsers, you may come up with a solution. I think a lot of developers already do this on the back end. So they do all of the cropping on the back end before sending the cropped image to the front end. But you don't even need to do that. Using this small SVG snippet, you can do exactly that. So instead of embedding, can you see the code? So some of you are doing this, some are this, some are this. So I'm going to go through the code shortly. Using this snippet, you can, instead of embedding an image tag on your page, you would be embedding an SVG. Okay? The SVG has a width and a height, a view box. It always has a view box, and it has a preserve aspect ratio. Usually, you can omit the preserve aspect ratio and let the browser handle everything. But if you're going to be doing something like this, you want it to be there, and you want to change the value. Now, inside of the SVG, you have an image tag, IMAGE, the SVG, the XML image tag. You link to the user uploaded image inside of the image tag. Okay? The width and the height of the image are set to be 100% by 100%, which means that they will scale up to fill the entire view box, not the viewport. Okay? The SVG width and height determine the viewport, so which is going to be, for example, a square on your page. The image may not be square, so you have some white space inside of the SVG. The view box value is going to be 0, 0, image X and image Y. The image X and image Y are going to be the width and the height of the user uploaded image. So try to imagine it. You have a square, and you have, which is the SVG, and you have an image inside of the SVG with a different aspect ratio. The view box has the same dimensions as that image, so we get the exact same thing we got earlier, the white space on top and on the bottom, okay? So in this case, what's happening here is you've used SVG just as a regular container for your JPEG image or whatever, PNG image or raster image, okay? It's not, you're not using SVG as an image format anymore, you're using it as a document, just like a div in HTML. It's just a wrapper here. Now, using the preserve aspect ratio, you can specify the alignment if you want it to be contained, if you want it to be covered, if you want to move it inside of it. Cropping, scaling, everything happens like this. So an example would be the width and the height of the SVG could be 140 pixels. The user uploads an 800 by 500 pixels image. You link to that image, and then all of the work is done in the preserve aspect ratio. You probably, if you want to do the kind of cropping that CSS does by default most of the time, it would be preserve aspect ratio slice, which is similar to cover, and X mid, Y mid. So the image is cropped to a square without using a single line of CSS, and with browser support that goes way back. You're going to see it shortly. This code is missing something. So you've replaced an image tag with an SVG, but it's missing something. What is it? Say it out loud. Yeah, the alt tag. You should never serve an image without an alt tag. Even if the image is just decoration, keep the alt tag empty as long as you keep it there, okay? So we don't have any alt tags on image elements inside of SVG, but we do have an alternative. We have the title element inside of the SVG. The title element is similar to an alt tag, so you can give your image a title. You should always include a title for all of your SVG images if you can, or if they are not simply just decoration. You can even add the desk element, which is short for description. So if you want to add a title and a description to your image, you can add that. And this snippet here gives you all kinds of scaling and preserving aspect ratios in HTML all the way back to IE9, because IE8 does not support SVGs. No CSS required. Now, suppose you've cropped your image to square dimensions. The next step is to make it responsive, okay? Maintaining aspect ratio in CSS while making the image fluid is not very easy. So if the browser width, if the width of the image is 100%, how do you tell the browser that you want the height of the image to always be equal to the width of the image? Now, in future CSS specifications, there will be a way. So Tab Atkins told me that they will be speccing out something so that we will be able to preserve aspect ratio in CSS sometime soon. But right now, we cannot do that. So this is particularly a problem for inline SVGs, or SVGs embedded using an iframe. By default, the default size for replaced elements in CSS is 300 pixels by 150 pixels. Replaced elements are elements like an iframe, where the size of the iframe is not really defined by the iframe itself, it's defined by the contents. And because you don't really know the size of the contents, the browser doesn't know the size of the iframe, and it's going to give it, in that case, a default size of 350 pixels by 150 pixels. An inline SVG, if the SVG doesn't contain any content and it doesn't have any dimensions or anything, if you've ever maybe created an SVG sprite, the SVG sprite contains symbols that are not displayed on the page. Maybe some of you may have run into this where you get some empty white area on the page and you don't really know where that came from. It's because of that. SVG is a replaced element, and the browser is going to be giving it 350 pixels by 150 pixels unless you tell it otherwise. Now, when you embed an SVG inline, it's going to be, as long as it has a view box, it's going to scale as you expect it to in all of the browsers, except in IE. So what IE is going to do, it's going to make the width of the SVG scale as you would want it to scale, but it's going to fix the height to 150 pixels because it's dumb. So in order to fix that, and in order to preserve aspect ratio for anything, essentially, in CSS, you need a technique which is commonly known as the padding hack. So I'm going to go over how it works and then show you an example. So to make an SVG responsive with a preserved aspect ratio, first, you wrap the SVG in a container. Now, I want you to remember the last thing that we did. Okay, so we have an image or an SVG with a specific aspect ratio. And that SVG contains an image, a raster image inside of it with a different aspect ratio. Now what you need to do is you need to make sure that the SVG scales up and down while maintaining the aspect ratio of the image inside of it. Okay? So in order to do that, you wrap the SVG in a container, you collapse the container's height, you give it any width value that you want. It could be 100%, 70%, 50%, whatever. And then you apply the padding top. As Dennis mentioned something at the beginning of his talk, when you set the padding in CSS using percentage values, it's going to be relative to the width of the element, not the height. So even if you say padding top 50%, padding top is going to be set 50% of the width of the element, not 50% of the height. So if suppose you've collapsed the height of the container, it doesn't have a height anymore, it's height 0. And then you apply a top padding to that element. So you're expanding the height again, but the height this time is created by the padding, and the padding is set in percentages, which is relative to the width. So you have a height that is relative to the width, and you've established an aspect ratio. So we want our container here to have the same aspect ratio as the Svg View Box, which is the image inside of it. I know this is a little bit too much, but it's really cool. So how do you determine the value of the padding top? It's with this formula. So you get the aspect ratio of the Svg View Box in this case, Svg height over Svg width, and then you multiply it by this value. All right? So you have Svg contained inside of a container. The Svg is still there. You've collapsed the height of the container. Okay, so now the Svg is hanging outside of it. And then you've added a padding to the container. Cool, but the Svg has been pushed down now. So in order to put it back into the container, you're going to need to be using absolute positioning. So you have to start by creating an creating a positioning context on the container by using position relative. And then you position the Svg absolutely inside of the container, and you've established an aspect ratio responsively. And this is what it looks like. Oh. This is a video, it should work. Yeah. So I have an Svg here. Oh, I don't see it here. If I change the preserve aspect ratio value, now I've cropped the image inside of it. So this is one of the things you can do. I don't see the cursor. Now, you can also change the aspect ratio of the entire viewport, and it's responsive. No matter what the aspect ratio of the Svg, is going to be fully fluid and responsive. Okay. Another thing you can do with Svg. So in the first section, we covered how Svg is used just as a mere container for raster images in order to crop, scale, and manipulate them any way you want by while also preserving aspect ratio. Now, JPEGs have better compression ratios than PNGs for photographic data. JPEGs, generally speaking, they always have smaller file sizes than PNGs. Now, what if you could get the compression ratio of a JPEG while serving a PNG image? So you would serve a PNG image with transparency, but you would get the compression ratio of the JPEG. Surprise, surprise, you can do that using Svg. Now again, our Svg will serve as a mere container for a bitmap image, and then we'll use some Svg magic, which aka is Svg Masks, to get the transparency of the PNG while serving the JPEG. Now the idea behind this technique is to use an Svg mask to clip out the areas of the JPEG that you do not want to see, that you want to be transparent. So we end up serving a JPEG with simulated alpha channels, thus combining the transparency of a PNG with the compression rate of a JPEG. For example, suppose we have the following image here. The image on the left is what we want to display. It is a PNG image with another bird inside of it. So we start with a JPEG version of the image in the middle. It doesn't have any transparent areas. And then you create a mask, a luminance mask in this case, to mask out the areas of the JPEG image that you do not want. Okay? So the luminance mask means that the luminant areas of the mask represent the areas of the Svg that you want to keep. So the white area here is the dove, which we want to keep, and everything in black. When this mask is applied to the image in the middle, we're going to get the result over there using Svg. So we use Svg to apply the mask. So you have an Svg, you have a defs element. Defs element is short for definitions. anything you put inside of a defs element in SVG is not going to be rendered on the page. You're literally just defining templates that you want to be used or applied somewhere else. So inside of the defs element, I create a mask. That mask is actually an image. So you're using an image as a mask, straightforward. So we have the pigeon mask, we're referencing it here. And then you embed your JPEG image with the really cool compression rates, and you apply the mask to it at the bottom. I hope it's visible. I hope you can see it. And the SVG, the mask, and the image element have the same dimensions because it's the same image. And this is all you need. You're serving a JPEG, so you get the compression of the JPEG, and you're making it transparent using SVG masks. Now, one of the most frequent questions that I get here is, how does this work with responsive images? So if I only serve the 1x or 2x versions of the image, what if I want to serve 1x, 2x, 3x, depending on the resolution of the image? I've not tried that yet, but I imagine you could use a foreign object. So a foreign object is an element in SVG which tells the XML parser that the content inside of me is not really XML. So you could use picture and source set, I imagine, I haven't tested it yet. But you could use maybe picture, source set, all kinds of HTML stuff inside of the SVG. So you would replace the image element here with a foreign object that contains picture and source set, and you would still apply the mask to it, and you get the compression that you want. Now, just like you can optimize raster image delivery with SVG, you can also optimize SVG delivery with SVG. So I worked on the new Smashing magazine redesign, which I don't know when I think it will get public soon, but we've been saying soon for like a year, so I'm not really sure. You should ask Vitaly. One of the things that we had in the new magazine is we have these 3 new membership plans. Okay? I built the front end, so I had to embed all of these things. Now, for every membership plan on the membership page, we have a title, a name for each membership type. One of them is supporter, member, I feel smashing. They have changed. These illustrations have also changed, but the technique behind them is still the same. Plus, the cute Vitaly illustration is really nice. So, one thing, there are a couple of important things to note here. The text inside of these images, first of all, these images are used instead of the headings. So you have a section that describes the supporter plan, but that section does not have a title. So when it comes to accessibility or reading in general, you need a title for that section, right? The title is inside of the image, which means that the text inside of this image needs to be selectable, searchable, and accessible. Now, there are a couple of things. When you have an SVG, even though this is a perfect candidate for SVG, you need to first test that SVG is actually a good candidate for the image. So at first, when I saw these illustrations, they have a lot of details. I imagined that, well, when an SVG contains a lot of effects, a lot of details, a lot of information, the file size of the SVG can get so big that you're better off using a PNG instead. So at first, I thought, okay, I need the text to be accessible, so I need it as an SVG, but I need to test the performance first. Luckily, the SVG size was exactly the same as the PNG size, so I was good. I was able to use this. I can use SVG. I can have the text inside of it. The text inside of the SVG, unless you turn it into outlines, which means shapes, it's going to be searchable, selectable, accessible, just like HTML text. Users can select it with a mouse. SEO, all kinds of stuff comes with it by default. So after deciding I was going to go with SVG, I had to start to think about what kind of embedding technique am I going to use. We have 7 ways to embed SVGs on a page. Which one should you use? The answer to that question is always it depends, it depends, it depends. So since I want the text to be searchable, selectable, accessible, and I want to be able to apply the font face, Miha in this case, to that text, there are 2 ways you can do that. First of all, you can have the SVG be external, reference that SVG externally, but in that case, you would have to go into the SVG, define the font face there, and then apply to the text, which means that you would have to maintain 2 sets of styles in the main CSS and in the SVG. I didn't want that, so I try to only have 1 source of truth as much as possible. So I figured I could do it inline. If I embed these SVGs inline, I will get all of the benefits, and I will go into the main style sheet. I will apply the font face to this text, and it works. It does work. But I couldn't really, imagine having to embed this inline in your HTML. It's not done yet. Not yet. This is only one of them, not all 3 of them. Every one of those illustrations was so huge. So I didn't want to embed the SVG externally. I wasn't going to embed it in line like this. So I needed to come up with a better solution. And that is when I started thinking, I mean, I can go into the SVG and I can change the code inside of it. So I thought, why don't I get the benefits of SVG text, also serve the benefits of an SVG illustration, but separate them. So I thought I could separate the illustration from the text inside of it and see how that works. So I ended up doing something like this. I had an inline SVG in the text. I went into each one of those illustrations and I removed the text from them. Okay, so right now I'm referencing an SVG inside of an inline SVG. I'm getting HTTP cache. I'm getting caching. There's going to be an extra HTTP request, but that's okay. The file size wasn't really big, and we're going to be able to cache the image, which is really good. But the image does not now have any text, so I thought I could just add the text inline. And you position the text, because both the illustration and the text here are part of the same SVG, so you have an SVG that contains an SVG and that also contains a piece of text. What you're left with in this case is to just position the text on the illustration in a way that gives you the result that you initially had. So then if you want to go on and style the text, apply a font face, apply a fill color, make it bold, style it, you can do that from the main style sheet without having to maintain two, like the SVG in one place and the page in another page. But I have something wrong here, and it's intentional. I didn't know it when I built the site, but later I did, but I keep it on the slide intentionally. So supporter is written in all caps inside of the HTML. This is not good. Screen readers are going to read this out loud as SUPPORTER, and you don't want them to do that. So, FYI, always make sure that your text is set in regular caps inside of your HTML, and if you want to make it all caps, do that in CSS. Conditional processing. Now, you can again use SVG to handle SVGs or other SVGs, or you can use SVG to serve SVG while also providing non-SVG as a fallback. And this is like, okay, the SVG document structure specification defines elements and attributes, namely the switch element with 3 attributes that give us the ability to specify alternate viewing depending on the capable blah, 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 which essentially means that it checks if the browser is going to, if it has support for SVG. If it does, you serve a specific thing, and if it does not, it gives you the ability to provide another thing as an alternative viewing experience. Now, the 3 attributes on the switch element serve as sort of an if statement or conditions. If the conditions are met, then the switch statement is true, and the first element inside of the switch statement is going to be rendered. So this is an example here. Suppose you have a sprite sheet that contains a set of icons. Every icon is defined inside of a symbol element. You have a sprite sheet, essentially. This is an inline SVG. Inside of an SVG, I have the switch element, which is like switch case in JavaScript or if else. The first element inside of the switch element is the use. Use is referencing some icon Twitter. So it's an SVG icon. Okay, and it's the first element inside of the SVG. Oops. Okay. The second element is a foreign object, which I mentioned before. The foreign object means that everything inside of this area, this foreign object, is not XML. So the foreign object allows you to embed non-SVG inside of an SVG. Okay? Inside of the foreign object, I have an empty div, which will serve as a fallback. That div is going to have a background, which is the icon, but as an SVG, as a PNG format. So what happens here is, if the browser supports SVG, it's going to come to the switch statement. It knows SVG, so it's going to render the first element inside of it, which is our SVG icon. If a browser does not support SVG, it's going to ignore the first line. It's going to, oh, you can't see my mouse. It's going to ignore the first SVG root element. It's going to ignore the switch because it doesn't know what it is. It's going to ignore the use because it doesn't know what it is. It's going to ignore foreign object. So this is just the parser going through the elements. It ignores foreign object, and then it comes to a div. Hey, I do know HTML, so I am going to render this div. And this div happens to be an empty div with a PNG background image. which is our fallback for the SVG icon. Now, some browsers that do support SVG are going to download both images or request both images. They're going to show the SVG icon, but they're also going to request the PNG, which is something you do not want. So in order to prevent that, you can add another SVG to the same page. Both of them are in line. Now, in the second SVG, you hide the background image in the first SVG. Any styles in the first SVG will affect the elements in the second and vice versa. Pretty cool, huh? There's a lot of SVG inception, but it's really like, and I know I'm going fast, but I don't want to be taking up all of your lunch break or your coffee break. This is also, you also have the same problem if you use an object to display an SVG. Object is my absolute favorite SVG embedding technique because it allows you to script the SVG using JavaScript, animate it, style it, you get the caching, you get the performance and everything. So between the opening and closing object tags, you provide the fallback for the SVG. You reference the SVG in the object type attribute, all good. If a browser supports SVG, it's going to display that. If a browser does not support SVG, or if the SVG fails to load, if it doesn't find the SVG, it's going to go into the object tag, the contents of that, and it's going to use the content inside of it as a fallback for the SVG. Now, you can also, again, use an empty div with a background image, but make sure that you hide that as well to prevent any multiple downloads. Now, SVG can do more, and I'm going to show these examples again live. One of the things that one of my attendees at Frontiers showed me was this map here. So they have this history map for the history of Syria. This map, the actual map, is an image, a raster image inside of this viewport, which is an SVG. So you have an SVG container, an SVG document, and you're referencing an image inside of it. And these paths here, these circles, like if you go to the places and you want to highlight stuff, you can do that, all this using JavaScript. And then you can use even a little bit more of the SVG features to do this. Like each one of these colored areas is a path that has a fill color. And then some of them, I think it's already here somewhere. No, but one of the things that they have here is you can also use a blur on each one of these, so it's like you're doing heat mapping. So you would have a path, a colored path, you apply a blur to that, so you get some sort of heat maps, which is pretty cool. But what's even nicer is you can do this, which has been making the rounds on Twitter for a few days. So you're using SVG here to serve JPEGs or PNGs again, but you're making the experience a little bit nicer. So you're serving an outline, which is an SVG path. You're serving an outline of the actual image that you're loading. So if I refresh it again, these are SVGs in an SVG container. And once the images are lazy loaded and they're ready to be displayed, you display them inside of these SVGs, which is pretty cool. And because it is really useful, someone on Twitter, Emil, he created this Webpack loader that exports traced outlines as images. So you give it your images, it's going to create those SVG outlines for you, and then you can embed it. He even created other stuff, like you can create these blurred previews as well, which is pretty cool. And my last slide is a thank you slide. So thank you.